Hello. So for the second part of our first section, we're going to be looking more closely at chemical equations and specifically balancing them. So the first thing we have here is what's called a word equation. A word equation is exactly what it sounds like. It's an equation with words. So instead of the formulas for the compounds or elements, we have just the names of them. Aluminum plus bromine yields aluminum bromide. Right? It's just a word equation is a chemical equation with words. And then what we can do is once we have a word equation, we can sort of translate that into what we call a skeleton equation or an unbalanced chemical equation, this time with the actual formulas of the compounds. And one thing that students often will forget here is they'll forget the things that they learned in chapters 8 and 9. So for example, when it says aluminum plus bromine, you need to remember that bromine is diatomic, so its formula will be Br2. Similarly, if it says it forms aluminum bromide, you need to remember that that's an ionic compound. Aluminum is 3 plus, bromine is 1 minus, and then we have to crisscross the charges to get AlBr3. So just remember that when we go from a word equation to an unbalanced chemical equation with the formulas, we need to make sure that we are writing our diatomic elements as such. We're writing the formulas for ionic compounds correctly. So here's a couple examples of those. Hydrogen and bromine gas react to form hydrogen bromide. Okay, so hydrogen and bromine gas. Now I remember hydrogen and bromine are diatomic. So hydrogen gas is H2 and bromine gas is Br2, right? And in parentheses, we put that little G. Hydrogen bromide is HBr, and that also is a gas. Carbon monoxide and oxygen gas react. Carbon dioxide is produced. These are a lot of covalent compounds here. Carbon monoxide means CO, right? Mon means 1. Oxygen is also diatomic, reactive form, carbon dioxide, CO2. This one, it has a lot of ionic compounds in it. An aqueous solution of lithium phosphate is mixed with an aqueous solution of cobalt-2 nitrate to produce an aqueous solution of lithium nitrate and a solid precipitate of cobalt-2 phosphate. So we have to take each one of those and make them into the formulas. So lithium phosphate, lithium is Li plus 1, phosphate is PO4 3 minus. So lithium phosphate is Li3PO4, and it tells me it's an aqueous solution, so I write AQ after it. Cobalt-2 nitrate, so cobalt-2 is cobalt-2 plus. Nitrate is NO3 with a 1 minus charge. So cobalt-2 nitrate is CONO3 2, and that is also aqueous. And then it says that it produces, so that's where my arrow goes. Lithium nitrate, lithium is plus 1. Nitrate is 1 minus. So LiNO3, that is also aqueous. And then cobalt-2 phosphate, and that is solid. So CO3 parentheses PO4 2, and that's going to be a solid. So that's taking that word equation and translating it into a skeleton equation. But as we can see, this actually is not what we're going to call balanced. If I look at this tells me there's 3 lithium. I'm starting out with 3 lithium ions, and then at the end I only have 1 lithium ion. That doesn't make any sense. According to the law of conservation of matter, matter is never created nor destroyed. So those 3 lithium ions that I had in the beginning have to be there in the end. And that process of making sure that that happens is balancing, making a balanced chemical equation, the same number of atoms of each element on both sides. And the only thing that we can change when we balance a chemical equation are just the coefficients. Remember, aluminum bromide is AlBr3. It's because aluminum is a 3 plus ion and bromine is a 1 minus ion. So it has to be AlBr3. It doesn't matter that there's 2 bromine on the left-hand side. It can never be AlBr2. But what I have to do is use coefficients in order to make sure that if I start with 6 bromine atoms, I'm going to end with 6 bromine atoms. So how do we do that? These are 5 simple steps that you can sort of run through every time. The first thing is you make sure that your skeleton equation is correct, so that the formulas for all the compounds are right. And then making an element inventory. It's just a fancy name for really taking a look at how many atoms of each element there are. And then, of course, we add coefficients. Those are the only things that we can change. We never change the subscripts. So there's a couple tips here. If an element is present by itself on one side of the chemical equation, if you leave that to the last to balance, that will often make it easier. And if you notice a polyatomic ion, instead of trying to balance the individual atoms that make up that ion, just balance that ion as a unit. When you're done, you make sure that the coefficients are the lowest number possible, and you can always go back and check your work. So here is an example with sort of all the steps that you would normally do. This is cellular respiration, right? This is glucose plus oxygen. And when I look at this equation, the first thing that I notice is that there's 6 carbon over on the left-hand side, and there's actually only 1 carbon on the right. And so I need to change that. I need to make sure that there are 6 carbon on the right. And I do that by adding a coefficient of 6 in front of the carbon dioxide. Now that means I've changed the amount of oxygen. That's okay. If you notice, oxygen is all by itself over here. So I can leave that to the end to balance, and that's going to make my life a whole lot easier. Now the next one, now that I've done that, there are 12 hydrogen. And I notice over here there's only 2 hydrogen from the water. So I add the coefficient of 6 there, because 6 times 2 is 12. So now I've balanced my carbon and I've balanced my hydrogen. Now I can really think about, what about the oxygen? If I look at the right-hand side, I can see that there are 6 times 2, or 12 oxygen from here, and another 6 oxygen from the water. So there's a total of 18 oxygen on the right. I need to make sure that there's 18 oxygen on the left. Well, I'm not going to really fiddle around with the oxygen from the glucose itself, but if I add a 6 coefficient to the oxygen gas, now there's 18 oxygen on the left and 18 oxygen on the right. And every single one of these problems, you can always check your work. So it means that there's really no reason to get these incorrect on the test. You just need to make sure that you're always, keeping track of what you're doing. So there's 6 practice here, and we'll go through all 6. And if at any time, you want to pause and try some on your own, I really suggest that. So the first thing I'm going to do is draw like a little line under the arrow to separate the reactants from the products. And then, like I said, take an element inventory. How many atoms of each element are there? On the left-hand side, there's 8 sulfur. On the right-hand side, there's 1 sulfur. On the left-hand side, there's 2 oxygen. On the right-hand side, there's 3 oxygen. And it doesn't matter what order you balance them with. I usually just go from left to right. So to balance out the sulfur, I'll add a coefficient of 8 here. When I add a coefficient of 8, this is now a multiplier to both of those. So I'm going to cross out that, and it gets multiplied by 8. And I'm going to cross that out. It also gets multiplied by 8. 8 times 3 is 24. So now the sulfur is balanced. I need to balance out the oxygen. I need to think what number times 2, because it has a subscript of 2, will equal 24, and that's 12. If I do that, 12 times 2 is 24, and you can see now I have the same number of atoms of each element on both sides. Okay, this chemical equation has zinc, hydrogen, and chlorine. There's 1 zinc on each side. There's 1 hydrogen on the left and 2 on the right. and 1 chlorine on the left and 2 on the right. So my zinc is balanced. To balance out the hydrogen, I'm just going to put a 2 here. It's a multiplier, right? So that means 2 hydrogen, but also 2 chlorine, and that just balanced itself out nice and easy for me. This is the first one with a polyatomic ion. So I'm going to look at how the silver, and I'm going to call them nitrate, and copper, right? There's 1 silver on this side and 1 silver on the right. There's 1 nitrate group. So I'm taking this whole group as an entire group. On this side, how many nitrate are there? There are 2. And there's 1 copper on each side. So the only thing I need to balance out are the nitrates. If I put a coefficient of 2 here, remember it applies to both of those. So although I will increase my nitrates to make them balance, I will also unbalance my silver, and that happens all the time. I just put a coefficient of 2 over there to balance out my silver. So now that we've done 3, maybe this is a good time to pause and try the next 3 on your own. Okay, this has 2 elements, iron and oxygen. There's 1 iron on the left and 2 on the right, and there's 2 oxygen on the left and 3 on the right. Now, one thing that happens fairly often is when you have a situation where there's 2 on one side and 3 on the other, how do I get them to balance? If you think of the idea of least common multiple, that can help you, because I know that I could make them both fairly easily into 6. How could I get 6 oxygen on the left? Well, I could multiply that guy by 3. How could I get 6 oxygen on the right? I could multiply that guy by 2. But that's going to change my iron to 4, and I could just simply put a coefficient of 4 there. Remember, iron was by itself, so if I leave iron to the end, it makes it really easy to balance. Okay, this is iron and oxygen and hydrogen. There's 1 iron and 3 iron over here, one oxygen and 4 oxygen over here, and 2 hydrogen and 2 hydrogen over here. Again, I could balance out my iron first, but because I know I have iron by itself, it might actually be easier if I try to balance out my oxygen first. So if I try to balance out my oxygen first, I put a 4 here. That makes oxygen 4, but that makes my hydrogen 8. No big deal. I just put a coefficient of 4 there, meaning my hydrogen goes up to 8, and I still just need to balance out my iron with a 3 there. And then finally, phosphorus and oxygen. There's 4 over here, there's 2 over here, there's 2 oxygen, there's 5 over there. 2, and I could pretty easily make, well, I can do this actually in a couple different orders. In order to balance out my phosphorus, I could put a 2 here. That makes my phosphorus into 4 and my oxygen into 10, and then a coefficient of 5 makes that oxygen at 10. So every time that you are balancing, be sure to update your element inventory. And, you know, this is the first, as we're first doing it, we do this element or inventory out, but eventually you really won't need to. When you do this on a test, you don't need to write out the element inventory. If you want to simply sort of do it in your head, you could do it in your head by looking and saying 4 phosphorus, 2 phosphorus. So put a coefficient of 2 there. 2 times 5 is 10, coefficient and 5 in front of the O2. So you don't have to do the element inventory, but it is a good trick to use, especially as you're first learning.